Why is that?
I don't know. Basically, it changes the bootstrap optimum or something like that.
Oh yeah. Well, but there is. Is it all bootstrap? No. There are different methods you can try.
Yeah, and so there's that one. There's also the one like MGG or something like that, and CM. But they all change no matter what. Like, so I don't know what to do about that.
I don't know. Well,
because like, it definitely the p-value when it's symmetric is when you just test it against the null hypothesis of it, no, the alternative hypothesis of it being asymmetric.
yeah.
The p-value gives us like 0.11 or that, so it's high enough to like say it's an asymmetric data. When you test it skewed to the right,
You don't need to check for skewness. We just test for symmetry or not symmetry. That's it. You don't need to check for skewed version. Why do you want to do that?
but then if you're but it kind of like varies, so it can go from like 0.9 to 1.3 for example. But then aren't you going to have your p-value as 0.1 because you're using both sides of the test? That each critical region is only going to have 0.05, which means then it's just going between the two p-values, or you still use p-value as 0.05 for both sides.
No, anything greater than that is fine.
But I thought for a two-sided test that you use
More. Yeah. More of those. Just a minute. I have them here. Not much. All of what you want.
So what do I do about what p-value do I write that I got?
I don't know, man. I mean, just write. Just do one of those tests and write the p-value. I don't know. I haven't tried the test myself, so I don't know how it works.
Yeah, I don't know how it works. So if I just take the one p-value, which is I get.
Yeah. Yeah. Just write down.
Do I not need to check for if it's skewed to the one side? Just. Yeah.
Thank you. Thanks a lot. Yeah, thank you. Can you guys do question 1, please? Question 1. These are the summary of the confidence intervals we did 2 weeks ago.
It was like the same probably right. Then you find out
You guys do question 1, please. Question 1. These are all the formulas you need to do question 1. Anybody else wants to handle quiz 9? Quiz number 9. you're going to use 90. Have you guys done question 1, please? Guys. Guys, tell me. Have you done question 1? Right, now tell me which formula should you use for question 1? Is it 1, 2, 3 or 4? Which one should you use? 2? Why? Why is it 2? Where's my glass? I can't find my glass. Shit. Alright, let's see. Right? So these are all the information that's given. So clearly, can you listen please? Clearly the question 1 doesn't say that sigma is the population standard deviation. It doesn't say the population standard deviation is known. So you need to use equation number 2, which is this one. This one here. The second one, this one, right? So it's gonna be, before that you need to work out the level alpha, because we want to find out the, what is that, 90% confidence interval. So 100 times 1 minus alpha is 90, which implies that 1 minus alpha is 0.9, alpha is 0.1, alpha by 2 is 0.05. Okay. Now using the formula is x bar minus n minus 1, which is 80, s, which is 11.3, divided by square root of 81. Okay, and x bar plus okay, this is the formula that I just showed you. Now we need to read this guy here. Now to read this guy you need to use the table. There are tables in front of you. Can you fetch them please? If you see the table in front of you, you see them or not? There is something called the T table. This is the T table. Now you need to look for 80, 0.95. Okay, so if you go down this table, this is column row 80. Yeah, this is row 80, and you're looking for 0.95, which is the third column. Right, so the number that you're looking for is this one here. It's 1.664. Right, so this becomes x bar, which is minus, multiplied by 11.3. Square root of 81 is 9. Alright, so that's the answer. If you have a calculator, you can work it out. Is that clear to all of you? Yeah? Right, can you do question 2, please? Question 2, please. I will put the formula sheet back on. Where is it? Oh, you're still copying. Is that okay? Right. You know the formula sheet anyway, so can you do question 2? This is the formula sheet back on, so you know which one to use. question 2 in the sheet. Guys, you done question 2? Right, would you listen please? To part 1, we are told that the sigma squared is 30 and we want to find a confidence interval for mu. So which formula should you use? Hello? Which you will use what? You will use the first formula, right? Which is x power minus you want the what, the 95%, is that right? 95% means this will be 0.975. Yeah. Sigma, which is 30. Sorry, sigma is square root of 30, and is also this. Now, can you listen please? How do we work this guy out? You need to look up the table, right? You look up the table for the normal distribution. No, this is not the one. Not this one, no. This is the table for the normal distribution, and you look for 0.975. Can you find it? It's this one here. It's 0.975. Right? So it corresponds to 1.9 over here and 0.06 over here. So it's 1.96. So this guy is equal to 1.96, right? So this becomes x bar minus 1.96 yeah. Guys, are you following what I'm doing? Hello guys, are you okay with this? Yes? Alright. Now part 2 is to do the same thing, but assuming that sigma squared is not known. So you see that the formula is the second formula, which is t. N minus 1 is 29. Alright, now to read this guy, to read these two guys, you need to use the t table. So go to the t table. You know where to find the t table. And it's 29.975. So it's 29 is over here. This is your 29. Yeah, and your 0.975 is this column here. This is your 0.975. So the number that you're looking for is this one, 2.045. Yes? So this guy yeah. You see that or not? Okay, so this becomes x bar minus 2.045 multiplied by s divided by square root of 30 x bar plus okay, this is what you get. Now S is the sample standard deviation. There is a formula for S I gave you some time ago, long time ago maybe. I think it's in the printed notes, which reads something like this: 1 over n minus 1 times the sum. Do you remember this formula? Yeah? This is the formula for S. Now you need to use this formula. I'm not going to do it now, but you need to use this formula to compute the value for S, right? And once you got the value for S, you sub it in here, and you know the confidence interval, right? That's part 2, right? Now part 2 is also asking you to asking you to find a confidence interval for. We're not finished with part 2 yet, because we need to find a confidence interval for sigma squared, which if you look at the formula sheet one more time, remember the formula sheet, right? This is the confidence interval for sigma squared, right? Yeah. So the CI star squared, n minus 1 is what? 29. 1 minus alpha by 2 is 0.975. So this is the lower limit. The upper limit is going to be chi squared 29 0.025. Now we need to use the table one more time to read these two guys here. Now if you look at the table for the chi-square distribution, which I gave you, which is in front of you, when you find the table, guys, here we are. 29, this is the table for the chi-square. If you look at 29, this is the 29 for all. And we need to look for 0.025, which is this one, and also 0.975, which is this one. So, oh, you can't see it. You need to look for 0.025 and 0.975, this and this. It is in front of you, guys. The table is in front of you, okay? So this guy here is equal to 45.722, and this guy here is equal to 16.447. That's it. You just sub it in, you're done. Are you okay with this, guys? Okay. And the numerator you can compute using the info that you are given in the question number 2. Right. Yes. You okay? Yeah. We got that clear now. Yes. And the question 32. Question 32. Look up this computer. You still type this by head. Yeah. You just put this and solve this problem. Solve this inequality problem. I think there's in the last tutorial. You were there. Have you done question 3, guys? The formula. You need the formula. What do you mean, the formula? You need the formula for question 2. Is that right? Yeah, these are the formulas there. These are the formulas for question 3. I mean. Question 3, the formula is what? Which formula should you use? I mean, there are 4 formulas, guys, but the screen is not large enough to all of them. There are 4 formulas. Which one should you use? There are 4 of them here. Okay. You guys done question 3? Hello? So which formula should we use for question 3? Which one? Huh? The last one, of course, right? Because this is the only one about proportion, so this is the one you should use, right? Okay, so let's see. So n is 800. X bar is the sample proportion. Now what's that? What's the sample proportion here? Is which is and 100 times 1 minus alpha is 90. Right? So 1 minus alpha is 0.9, alpha is 0.1, alpha by 2 is 0.05, 1 minus alpha by 2 is 0.95. Okay? So the confidence interval you want is x bar, which is 4 by 25 minus Okay. Now how do we read this, guys? Hello. How do we read? We need to use the Z table to read. We need to use the Z table to read 0.95. So you put the table in front of you, and you find 0.95 here, guys. Where is it? It's halfway between these two, right? 0.95. So this is 1.6, 0.04 or 0.05. So it's halfway between 1.64 and 1.65. Okay? So this guy and this guy are equal to alright, guys? Is that clear or not? Can you do question 4, please? Now question 4. Yeah, N is 800. N is 800.
Is it 500?
Is it? Is it 500? Sorry. Sorry, guys. It should be 500. See, I can't. $500, not 800. Yeah. I apologize for that. Yeah, it should be 500, not 800. Can you do question 4, please? Question 4. Guys, all of you sign definitions. Yeah, try. Just only do the first part of question 4. Ignore the remaining parts. Only do part 1. Part 1 of question 4.
Huh?
Enjoying too much, I said.
Yeah.
Alright guys, so let's do the first part of question 4. Now we know the 100 times 1 minus alpha percentile CI for mu is x bar Alright guys, shh. This is the confidence interval, right? Now what is the width? What is the width of this interval? Come on guys, this the width, this minus this, which is what? 2 times z. Okay, this is the width. Now there are 3 things that affect the width. One is sigma, right? And you can see as sigma increases, width right? If you increase the value for sigma, the width will also increase because it's an increasing function, right? Now the second factor is n. As sigma as n increases, now what will happen to the width? What will happen to the width as n increases? It will decrease, okay? Okay, because it's a decreasing function of n. And finally, alpha. As alpha increases, now what will happen to the width if alpha increases? Come on guys, will it increase or decrease? Hello? Will it increase or decrease the width? You're right. Because remember, alpha by 2 is the area to the 2 tails. So if you increase the value for alpha, the interval becomes shorter and shorter. So the width will decrease. You understand what I'm saying? Remember, because the alpha by 2 is the area to the left and the area to the right. Yeah? So if you increase the value for alpha, the interval will become narrower. Okay? So that's the answer to question 4. You do question 5, please. Question 5. quiz 9, please. Quiz 9. Mr. Hand in quiz 9, please. Quiz 9. Alright guys, I mean question 5 is easy, you should know how to do it, alright, just use the result of question 4. Alright, and any questions on the R coursework or any other questions, just feel free to email me 24/7 or you can also Zoom me 24/7. Okay? I will be in Manchester during the Easter break, but I will see you guys next week anyway. Yeah. Yeah.
I'm sorry. Yes, a question about the quiz. I'm not asking for the answer.
Yeah.
Yeah, like when I'm writing the likelihood function, are these two the same? Are these two expressions the same?
Yes.
But I got different. This is, this is the process.
Thank you, man.
If I use the first one, this is about the same as last week's quiz. And so the thing we get is actually, I think this should be, x bar over n. And if you get this equation, I think this is the equation of x bar, you get n squared over n1 plus 2n. That's it, using this one. I think this, if these two are the same, then if you use the second equation, what I get here is this one.
I don't know, you must be doing something wrong, sir. I can't tell you like how. I can't tell you which answer is correct.
Oh, I'm not asking you which answer is correct. But if these two are the same expression, the answer should be the same, right?
Yeah. They should be the same, yeah.
So
They should be the same.
these two are the same, right?
Yeah, but I think remember last week I think you're mistaken here because last week we had n here. We had an n here. But you have 2 here, not n.
Yeah.
Yeah? So the answer, this answer is not correct. See, this answer is not correct. Because the last week you had n here and n here. This is the answer. But
Yeah.
now, this week you have 2 here and n here. So this is not correct.
But the problem is, my problem is, no matter how this change, this term, the binomial term, should be eliminated when you're taking the derivative, since it's always a constant.
Yeah. But
Yes,
still, you should have a 2. You have a 2 here, not n. This should be 2. Last week this was n. You see, last week this was n, but now you have 2, so it will make a difference to the answer.
Wait a minute. Let me check my process then.
You understand what I'm saying?
Yeah, I get what you mean.
Just think about carefully. I don't think you're. Just think about very carefully.
Oh, I'm sorry. That's your. papers.
It's okay. You can take it if you like.
Oh, fine, thank you.
Think about very carefully. Yeah.
So,
Both approaches should give the same answer.
okay, fine.
Yeah, they
I'm
should
just
give-
to make sure if these two are the same thing, because yeah, this is what I think. I think both of them correct. Yeah, that's why. And I
Both
got
are
the
correct,
thing.
but they should give the same answer.
Okay, fine then.
Yeah, they should give the same answer both ways.
Okay, I will check it.
Okay.
Okay, go back.
Come
Thank
ag-
you.
Come again. Come to see me if you have more questions.
Okay, fine.
Yeah.
Thank you.
Pleasure. Pleasure. Pleasure to help you.
Okay.
Do you need these papers?
No, I don't need them, madam.